In this video, let's go ahead and apply the angle bisector theorem to go ahead and solve for x. So in number one, we're told that segment BD bisects angle ABC, and that segment we're talking about is right here. Now we know it bisects angle ABC, which is this angle here. Because segment BD is an angle bisector, we know that these two angles here are going to be congruent to each other. Basically, when you have a situation like this, we can apply the angle bisector theorem, which states that an angle's bisector splits the opposite side of a triangle into segments that are proportional to the triangle's other two sides. Basically, this angle bisector of BD is going to split segment AC into these smaller segments of AD and DC. And so the ratio of AD to DC is going to be equivalent to the ratio of AB to BC. And so just writing this out to be super clear, we have this segment AD, the ratio of that to DC. This is going to have the equivalent ratio of BA to BC. And so substituting in, we can say this is going to be the ratio of 13 to 11. And this is going to be equivalent to BA, which we know is going to be X here in this case. So I'm going to put an X on top here. And on the bottom, let's go ahead and put a 16. If we go ahead and just use cross products here, this isn't too bad, but 11 times X is just going to be 11X. Go ahead and write that in. I'm not going to change the colors anymore. So 11X is equal to, and at 13 times 16, you can go ahead and multiply that out, but it's going to be 208. And then if we just go ahead and divide both sides by 11 here. I don't think this is going to go in nicely, but the directions do say round to the nearest tenths if necessary here. So I think we're going to go ahead and say that X is going to be approximately equal to, I think it's going to be about 18.9. So go ahead and check that on a calculator, but that should be about right. All right, this would be the value of X. All right, let's check out a second example. Once again, BD is going to bisect angle ABC. So here we have all that labeled, and we know that these two angles down here are going to be congruent. And so, just like the last example, we know that if we have this angle bisector, it's going to be splitting this segment AC into two very specific segments that we can use to set up a proportion. We can go ahead and apply that angle bisector theorem and say that the ratio of segment DC to AD is going to be equal to the ratio of the segments of BC to BA. Here's segment DC, and then we have segment AD. Then we also have segment BC, which is over here, and then we have segment BA, which is over here. Substituting our values in, DC is going to be X for now. Let's go ahead and substitute in X. And then AD, we're going to say is going to be 6. And that's going to be equivalent to the ratio of BC. We know BC is going to be 15. And what about BA? Well, BA we know is going to be equal to 18. Now, sure, you can go ahead and use cross products if you want, or you can see that 6 times 3 is going to be 18. So I know that X times 3 is going to be equal to 15. So if we know that 3X is equal to 15, then we can just divide both sides by 3 here. Dividing both sides by 3, we actually don't need to do any rounding, and we can say that X is going to be equal to 5. This would be our solution. Let's try a third example together. Once again, segment BD is going to bisect angle ABC, which are located here. So if BD is an angle bisector, we know that these two angles are congruent to each other. And if we go ahead and use the angle bisector theorem, we know that we can break up segment AC into two smaller segments that are going to form an important ratio together. Basically, the ratio of AD to this DC is going to be equivalent to the ratio of BA to BC. Let's go ahead and write that out so it's super clear. So segment AD, the ratio of that to segment DC, that's going to be equivalent to what? It's going to be equivalent to this segment of BA, the ratio of that to segment BC. If we go ahead and make some substitutions here, AD we know is equal to 8. Let's go ahead and substitute in 8 here. DC we know is going to be 10, so substitute that in as well. For AB, that's going to be X, so let's go ahead and just leave that as a variable for now. And then BC we know is going to be 11, so let's go ahead and substitute that in as well. Okay, so I don't see we could use the identity property well here, so maybe we can just go straight to cross products. If you find the cross products, 10 times X is going to be 10X, and then 8 times 11 is going to be 88. And then you can go ahead and just divide both sides by 10 here. If we go ahead and do that, This one's not too bad. X is going to be equal to 8.8. We don't have to do any rounding here either. This would be our solution. All right, here's one final example. One final time, segment BD is going to bisect angle ABC. And here they are just a little bit more clear. And since BD is a bisector or an angle bisector, we know we have two congruent angles. And when that happens, the opposite side of AC can be broken up into two smaller segments that are going to form an important ratio with each other. Basically, the ratio of AD to DC is going to be equivalent to the ratio of BA to BC. So writing this out, it would look something like this. We have the ratio of A to D. That would be the ratio of that to DC, or the other part of segment AC. So that's going to be DC here. That ratio will be equivalent to our other ratio of, what do we have here? We have BA to BC. Now, if we're going to make some substitutions here, AD we know is going to be 12, so substitute in 12 here. DC we know is going to be 9, so we have a 12 to 9 ratio. That's going to be equal to BA, well, that's going to be X. And then BC here, BC looks like it's going to be 19. So let's go ahead and put X to 19 is equal to 12 to 9. You can use cross products right away, or you can also simplify if you'd like to. So I'm going to actually simplify and divide these both by 3, just so I don't have to deal with as large numbers in case you don't have a calculator. This would be the simplified 4 to 3 ratio would be equal to this X to 19 ratio. So if you have a calculator, obviously it doesn't matter as much, but I don't have one here. So I'm going to go ahead and use the cross products. 3 times X is going to be 3X. And then 4 times 19, well, 4 times 20 is 80. So we need 1 less 4. So I think it's 76. So 3X is equal to 76. And if we just go ahead and divide both sides by 3 here, I know 3 times 25 is 75. So it's going to go in 25 whole times. And it's off by 1, so it's going to be 25 and a third. But I think we're supposed to be writing this rounding to the nearest tenths place, so we can say X would be roughly 25.3. It would round down, so it would just stay at 25.3. All right, so there you have 4 different examples of using these angle bisectors to then set up some proportions and then go ahead and solve for a missing side length. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep it the great work that you're already doing.